We now find r prime of t, which is the derivative of r of t. This r of t is given as 4 root t I plus t squared root t j plus natural logarithm of t squared k. So to find the derivative, we consider this one as x of t and the j component as y of t and the k component as z of t. So r of t is written as x of t times I plus y of t times j plus z of t times k. And this means if we find its derivative, we find the derivative of each of the components, that is x prime of t I plus y prime of t j plus z prime of t k. Let's say this is equation 1. Now from this comparison we can see that x of t equals 4 root t, and we will find its derivative because we need it here. So let's find this derivative. We can rewrite this as x of t. This equals 4 times of t power 1 by 2. Now let's find the derivative by differentiating x of t with respect to t. And so this gives 4 times of apply the power rule. We get half t raised to the power of half minus 1. This half minus 1 is negative half. So I write this as negative half. And so therefore this equals 4 divides into 2 as 2 times. This equals 2t power minus 2, or otherwise we can write this as 2 divided by t power positive half. And if we put this in radical form, this is equal to 2 by root t. We can in fact rationalize this by multiplying and dividing by root t. So this becomes 2 by root t times root t divided by root t. And so this gives 2 root t divided by root t times root t is t. So this is x prime of t. Now let's determine y prime of t. So first we will copy the y of t, and this y of t equals this t squared root t. So we have t squared times root t. Let's put this root t as t power 1 by 2. Now we combine these two products, t squared times t power 1 by 2. Using the exponent law, this will be t raised to the power of, we add the powers, and so this equals 2 plus half is 5 by 2, that is 5 halves. So this is y of t. Now let's find its derivative, that is y prime of t, by applying the power rule. So it becomes 5 by 2 times t raised to the power of 5 by 2 minus 1. 5 by 2 minus 1 is 3 by 2, that is 3 half. So I change this to 3 half. So here we have 5 by 2 t raised to the power of 3 by 2. And this t raised to the power of 3 by 2, we can put this in square root form. That is, first we write this as t raised to the power of half, and then we raise it to the power of 3, which is we cube it. T power half is written as root t, and then we cube it. So this equals root t multiplied itself 3 times. Root t times root t is t, and so we then have one more root t. So this is t root t. So this is written in another form as t root t. So therefore this equals 5 by 2 t times root t. This is y prime of t. Now let's find z prime of t. So let's copy the z of t, and this equals natural logarithm of t squared. So this one is natural logarithm of t squared. Now let's find its derivative, which is z prime of t, and this equals we use the formula to find the derivative of natural logarithm expression. So the derivative of natural logarithm expression is 1 divided by the expression of the natural logarithm. Here we have t squared, and also multiply by applying the chain rule, that is to find the derivative of t squared, which is 2t. And so this cancels, this power will get go off. So this one equals 2 by t. This is the derivative of z of t. And this means we can find r prime of t by replacing x prime of t, y prime of t, and c prime of t. So let's write the r prime of t. Therefore, r prime of t, and this equals x prime of t times I. X prime of t is 2 root t divided by t. So I write 2 root t divided by t I plus y prime of t j. So y prime of t is 5 by 2 t root t. So this is 5 by 2 t root t and j. And then finally z prime of t times k. So it is 2 by t times k. And so this is the r prime of t.